Welcome to our channel. In this lesson, I want us to discuss Form 3 chemistry, topic gas law, subtopic Boyle's law. This is lesson number 1. Now, objectives of this topic: by the end of this chapter, the learner should be able to state Boyle's and Charles' law, describe experiments to illustrate Boyle's and Charles' law, state and use the combined gas law to solve numerical problems, and finally to state Graham's law of diffusion and its application. Now in this lesson I want us to discuss Boyle's law. What does the law state? The law states that the volume of a fixed mass of a gas is inversely proportional to its pressure at constant temperature. Inversely means indirectly. Now molecular explanation of Boyle's law. When the volume of the fixed mass of a gas is decreased through compression at a constant temperature, the molecules travel a shorter distance to collide with the walls of the container, leading to increased number of collisions per unit time. This is a graphical representation of Boyle's law. You can see pressure is inversely proportional to volume. As pressure increases, volume decreases. Therefore, the constant here is temperature. The mathematical expression of Boyle's law is pressure 1 times volume 1 should be equal to pressure 2 times volume 2. So this is the formula that we will apply in solving problems involved in Boyle's law. Now, the SI unit of pressure is the Pascal, which is equal to 1 Newton per square meter. Now, other units used to express pressure are atmospheres, and therefore 1 atmospheric pressure is equal to 760 millimeter per mercury, or 1.01325 times 10 power 5 pascals. Note the SI unit of volume is cubic meter, and 1 cubic meter is equal to 1.0 times 10 power 6 cubic centimeter. Now here we have worked examples. Number 1, a volume of 375 cubic centimeter of a gas has a pressure of 20 atmospheres. What will be its volume if the pressure is reduced to 15 atmospheres? So you can see your V1 is 375 cubic centimeter. Your P1 is 20 atmospheres. The question is asking V2, and you have its pressure 2, which is 15 atmospheres. So you apply the formula P1 times V1 is equals to P2 times V2. Therefore, the answer will be 20 times 375 is equals to 15 times V2. So for you to get V2 now will be equal to 20 times 375 divided by 15, and therefore the answer is 500 cubic centimeter. Now example number 2, a given mass of a gas occupies a volume of 200 cubic centimeter at a pressure of 5 atmospheres. At what pressure will the gas have a volume of 800 cubic centimeter? So the question now is asking for P2. So you apply the formula, which is P1 times V1 is equals to P2 times V2. Our pressure 1 is 5 atmospheres. We don't have our P2, we are looking for it. Our V1 is 200 cubic centimeter, and our V2 is 800 cubic centimeter. And therefore it will be now 5 times 200 is equals to P2 times 800. And for you to get P2, it will be now 5 times 200 divided by 800. And the answer is 1.25 atmospheres. Now you have example number 3. A certain mass of a gas occupies 250 cubic centimeter at 25 degrees Celsius and 750 millimeter per mercury. Calculate its volume at 25 degrees Celsius if pressure changes to 760 millimeter per mercury in SI units. So our V1 is 250 cubic centimeter. We are looking for V2, and we have P1 750 while P2 is 760 millimeter per mercury. The question now is asking for V2 in SI unit, and you know the SI unit of volume is cubic meter. Therefore, your final answer should be in cubic meter. Therefore, the formula is P1 times V1 is equals to P2 times V2. And for you to get V2, it will be P1 times V1 divided by P2. Therefore, V2 now will be 750 times 250 divided by 760, and therefore V2 will be 246.7 times 10 power negative 6 cubic meter. Now question 4. At a constant temperature, a gas at 540 millimeter per mercury pressure occupies a volume of 300 liters. The gas is made to expand and occupy a volume of 600 liters. What is the new gas pressure in SI units? Remember, the question is asking for P2 and the SI unit of pressure is Pascal, so your final answer should be in Pascals. So our P1 is 540 millimeter per mercury, our V1 is 300 liters. So it is 300 liters. Our V2 is 600 liters. It is 600 liters. Therefore, for you to get P2, it will be now 540 times 300 divided by 600. And therefore, the answer becomes 270 millimeter per mercury. Therefore, you have to convert millimeter per mercury to pascals. And the relationship is 760 millimeter per mercury is equals to 1.01325 times 10 power 5 pascals. What about 270 millimeter per mercury? And therefore, your answer now will be 3.6 times 10 power 4 pascals. Thank you. That is the end of our lesson. For more videos, subscribe to our channel.